All right, everyone. I just want to say welcome to and for joining us to the Coreum workshop. Today, we're going to be going over IBC Smart Contracts. All right, and joining us today during the workshop is one of our core developers, Keen. And so Keen, if you just want to do a quick intro.
Yeah, sure. So hello, everybody. My name is Keen. I'm a smart contract developer in Coreum. And today we're going to cover smart contracts using IBC functionality. If you remember me, we did the last workshop about smart tokens and how to use them, sorry. And we also briefly introduced IBC in the last workshop, but today we're going to go more in detail and explore some advanced functionality with smart contracts. So before I start, let me quickly introduce what IBC is, if some of you are not aware or you're not familiar with the Cosmos technology. So IBC stands for Inter-Blockchain Communication, and it's basically a protocol to enable two blockchains to talk to each other, to communicate with each other. Okay, so how does it do this? So basically, blockchain create connections between them, IBC connections. And under these connections that are the transport layer, we will create channels, and these channels will send packets back and forth, and each blockchain will be able to read those packets, read this information, process it, and all this, right? So here is a quick overview, short overview of what IBC does in terms of packet flow. So when we have an IBC connection and we have an IBC channel set up between two blockchains, so let's imagine B is blockchain B and A is blockchain A, okay? We will have modules, core IBC modules. So for example, here we have IBC A and we will have core IBC B here. And in the middle, we will have relayers. Relayers are software that send the packets, so query the packets from one side, send them to the other side, receive packets. So these are like the tools that we use to send back and forth the packets that will go through IBC, okay? So we can have this is a successful example of a package sent over IBC, and this is what happens when, for example, there is a timeout. So when we send a packet through IBC, we can specify a specific timeout. If the packet is not received and processed by the other chain, then the relayer will say, sorry, it was not received. Here is your timeout packet, okay? So yeah, that's how IBC works in a general overview. Now let's go a little bit let's talk a little bit how this works with our smart tokens. So the advantage we have with our smart tokens, so our smart assets, for example, we have our fungible tokens assets and we have our non-NFTs. So since these asset FTs are native Coreum tokens, okay, they are not like ERC20 on Ethereum, or they are not like CW20 tokens on Cosmos. They are actual native tokens that use our bank module. We can reuse the IBC channels that we use for the core token to send, for example, when we send the core token to another chain, we can reuse the same channel that connects the transfer modules of IBC for our native assets. This is like the biggest advantage of having native assets on Coreum, right? We can use them like they are core tokens, like they are the native governance token of the blockchain. So let me go quickly how this would work, even though we covered it in the last workshop. Let's imagine that we issue an asset. Okay, so here we have a simple issue asset FT message where we define the symbol of the token, the subunit of the token, precision, initial amount, description, and here in the features, if we specify that the token will be IBC enabled, so let's go here for a second. For example, here, imagine we are sending in the feature, we're saying 0 for mintable, 1 for if you want to be able to burn it. And 4, this 4 stands for IBC enabled. So if we say this token will be IBC enabled, we issue it. Well, later on, we can do, for example, we could implement something such as mint and send. Sorry, not mint and IBC. Where is mint and IBC? IBC. Okay, here. No, IBC. Okay, mint and IBC. Sorry. It's here. So let's imagine that we say, okay, I have my smart contract, and my smart contract issued an asset FT, so a smart token, okay? With IBC enabled, I could easily mint tokens and at the same time IBC them to another chain. So for example, I have my message, my mint message here. I'm saying, okay, could you please mint me this amount? Okay. And then you are going to transfer it at the same time. After minting it, we are going to create our transfer message, which is a simple IBC message transfer. Since they are native tokens, since these asset FTs are native tokens that are in the bank module, like I mentioned before, we can reuse the transfer modules of IBC to send these tokens to another chain. So here we will say the transfer. We will say which channel ID we are transferring them. So for example, if you go to our tutorials here, you have a section called IBC, and here you could find all the channels. Right now we have Osmosis, Acceler, Evmos, Gravity Bridge. So let's imagine we want to send our token to Osmosis. Here we have the channel information. If we click here, it says channel 2. So we would have to write, channel 2 here. Which address in the destination chain we want to send it to. So here we will need to input our Osmosis address, how much we are sending, and finally, we are sending a timestamp. A timeout, which in this case, I'm using seconds. I'm using a number. So for example, imagine this message here, this mint IBC message. I can say here, okay, mint 10,000 tokens, send it to channel 2, which is the Osmosis one. The destination address will be Osmo blah, 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 blah. Okay, my Osmo address. And here I can specify how long my timeout of the packet will be. For example, let's imagine that I want my, if the packet is not processed in 2 minutes, I want a timeout. So I can just put in here 120 because I define it as seconds in my contract. If I'm not wrong, yes, I defined it as seconds, timeout. So I created timestamp with second. And that's all. That's all we need to do to use our smart contract with native assets and send them over IBC. It's very simple. You can basically copy this contract, deploy it, use it. It will work out of the box. Okay. So this is for sending native Coreum tokens to other chains. Let's do something a bit more advanced here. Let's close this. Don't save. And now let's go to this contract. So now, instead of sending tokens to another chain, I am going to deploy a contract. Sorry, I'm going to deploy 2 contracts, one on chain A and one on chain B. And I'm going to make them talk to each other. Okay, so if we look at the previous image that I had here, instead of having, let's imagine that our app, we have an app on chain A and we have an app on chain B. And here, instead of having the transfer module, I will have the contract A and contract B. So I will have a relayer that will transfer packets from one contract to the other and vice versa. Okay? Like, this is actually really cool. If we can manage to do this, we can have multi-chain apps. So we could have our app working on different chains, communicating with different chains. How do we do this? Okay, let's go first. Let's read the contract first, cover the key part of the contract, and let's talk about how we create the channel. So if you're familiar with smart contracts, you should know that we have like the basic entry points of the contract are instantiate, execute, and query, right? Like almost all the contracts will have these three main entry points, like instantiate, execute, query. Then you can also have like migrate entry point if your contract is upgradable, or you can have like a pseudo entry point if you're going to access your contract with Cosmos modules. But in general, most contracts, or I would say all the contracts, have these three entry points. If we want to make our contract IBC enabled, so if we want to have a contract that communicates with other contracts over IBC, we need to define the IBC entry points, which we specify here, and which are, by the way, all I'm saying here is in our tutorials. If you go to smart contract call tutorial, everything I'm explaining is explained more in detail here, okay? But I'm going to cover it while I'm showing you the code. So we are going to define 6 entry points, 6 IBC entry points. We are going to define the IBC channel open entry point, which, like you see in the comment here, it handles these two operations of the IBC handshake. We are going to define IBC channel connect, which handles these 2 operations of the IBC handshake. We are going to define the IBC channel close, which we will not go much in detail, but I will explain later. The IBC packet receive, the IBC packet acknowledgement, and the IBC packet timeout. So we have these 6 IBC entry points that, if we define them in our contract, when we upload our contract on the chain, we will eventually receive an IBC port that we will use to connect, to create channels connecting our contracts, okay? So let's go quickly over the different entry points. We have like I mentioned, we have the IBC channel open, okay? So when we create a channel, I will explain later how we create a channel, okay? When we create a channel and we use the IBC entry points for that channel, sorry, the IBC entry points of the contract for that channel, we will automatically enter this entry point of our contract. This is a very simple. It checks, it validates the order and the version. Let's see what this does. So I am receiving a message, a channel open message, and I'm going to validate the channel and the version. Let's go in here. So it checks, is the channel unordered? In the case it is not, we say, sorry, this contract works with unordered channel. We don't want an ordered channel, okay? Because IBC supports different kind of channels, but in our contracts, since we don't need the data to come in an ordered way, we say we want this ordered, okay? We want the channel, like you can see, we want the channel to be defined as an ordered channel. And it also checks the version. When we create a channel, it will say, what is the version of this channel? And the channel version, we define it in our contract here. We say, when we create this channel, we want the channel to be defined with the IBC version counter -1. If you look at our documentation, you will eventually find this here in channel version, okay? When we are creating our channel, we are specifying the version of the channel. This is some kind of security for saying we only want channels connected to this contract that have this specific version defined, okay? So we will create a channel. It will come in here. It will say, okay, if this is correct, it will accept the channel. And then eventually it will do it again during the connection phase. And additionally here, what we are going to do is we are going to save in storage. So we have a state here. We are going to save for each channel, we are going to save the number of times it has been successfully connected. And we are going to save the number of times it has been timeout. So like I showed you before, in this case, we initialize our connections to 0 because at the moment we are just creating the channel. So we are just connecting the channel. We are not transferring any data yet. So the counter will be initialized with 0. Okay. And once the channel is successfully created and these two entry points succeed, we will successfully have our channel created and ready to be relayed. Okay. So at this point, if this succeeds, we will have our state defined and our contract and our channel connected using the contract as an endpoint. Okay. Great. So now that we have our contract deployed and the channel successfully connected, we can start sending packets to this contract or from this contract. Because I'm not sure if I mentioned it before, but we are going to assume that we are deploying the same contract. So it's basically going to be like a ping pong, right? We're going to have the same contract on chain A and the same contract on chain B. So basically, this exact same contract, we will have it deployed on both chains. Okay, so let's go back to the tutorial here. We have the IBC Connect, we have the IBC Open, which we already introduced. Okay. What about the IBC Channel Close? So basically, we need to define it, but we will not go in here. We will basically never go in here. Why? This IBC channel close can be triggered by mainly two reasons. One reason would be if there is a timeout on an order channel, but this is not the case because like I explained before, we are only accepting unordered channels, so our channel will never be ordered. So this case will never happen. And the second scenario would be if the other chain is taken over. Basically, if there is a 66% stake, malicious validator is taking over the chain. So imagine a chain is compromised, then basically IBC has some security measures in place that it will close the channel. But to be honest, if this happens, if there is a malicious takeover, the last thing you have to worry about is your contract. So this is like, yeah, your channel will close, but to be honest, this has never happened so far. So even though we need to define it, we can be 99.9% sure that we will never enter this case, right? But in case it happens, what we are doing here is we're basically resetting the state for that particular channel, right? If we have a channel here, we are basically saying, put this back to 0, okay? And then we have the IBC packet receive. This is the key, the most important entry point. This is the entry point that our contract will use to receive information from another contract. So what I'm saying here is, if a contract sends an IBC packet to me, so if I am receiving a packet through IBC, come into this entry point. So what does it do? Let's see what it does. First of all, it checks the channel, the destination of the channel. Okay, it keeps the channel. It keeps the ID of the channel of the other chain where it was sent from. Sorry, and then it says it extracts the data of the package. Let's go into how the package looks like internally. So a packet has the relayer address, which we don't need, and it has an IBC packet. Let's go in here. And this packet has the endpoints, the sequence, the timeout, and the most important thing, what we are going to use is the data, which is wrapped in a binary, which is a base 64 array. So what we're doing is we are reading this binary. So we take the data of our package. We are parsing it into the execute message, which we define here. So if for some reason someone sends a packet that doesn't have this data, this will fail, because we are saying read this data and put it inside this structure. And this structure is defined as only this type of structure. It's an enum. So the only data type that we accept is increment. If someone sends something different, this packet receive will fail and it will throw an error. Okay. In the case it succeeds, what we are doing is we execute increment, which if we go in here is something very simple. We say we are going to take the connection count, we are going to take this channel in our map, and we are going to increase the counter by 1. We are going to say +1. Remember before we initialize it with 0. Here we initialize it with 0 with this key. So what we are doing when we receive a packet with the information increment, we are saying for this channel, increment the counter in 1. Sorry, where is it again? Increment here. We increment it by 1. Why do we have a mapping for channels? Why don't we have a simple counter instead of a map? Well, that's the thing. In our contract can have many channels connecting to it. So imagine instead of only one channel, we have 10 different channels connected to 10 different contracts, and we want to keep the counter for each particular channel. That's the reason why we have a map here that maps for each channel, keep the information of the counter, the number of the counter. Okay. So yes, so basically what we have is we receive the packet. If it's an increment, we increment by 1. Okay. And that's it. That's all our IBC packet receive does. It checks that the information you send is this one, and it increments the mapping, the value of the counter for that particular channel that you previously connected to. Okay. In the case it succeeds, you send an OK. If you don't send, if it's case it fails, you send an acknowledgement failure. Okay. The other entry point we have, and it's in our tutorial, is the acknowledgement, which basically when you receive a packet acknowledgement from the relayer. In this case, since we don't care at all, we don't do any logic because we are not going to process this packet, but we are still sending an event saying we received this. Okay, even though we're not processing anything, we're just sending an IBC basic response saying, okay, I received an IBC acknowledgement, so that if you have you can read on chain that this event has been triggered. And finally, if we receive a timeout packet because for some reason we sent something and it was not processed by the other chain, the relayer will send us an IBC timeout message. And in this case, what we are doing is we are keeping this in the same way we are keeping a counter for the successful connections, we are keeping a counter for the timeout connections, just for informational purposes. Okay. And again, we are sending a basic response and saying IBC packet. And I think that's pretty much it. That's how you process IBC packet receives. How do you send packages? Well, let's take a look. Very simple. Our contract has an execute message here, which is defined as increment channel string. Let's take a look at our contract. When we receive this message, increment with a channel ID, the only thing we're doing is we are saying, send the packets using this channel and with the data IBC execute message increment. Like I said, since the other contract is the same as this one, we need to send this one. Because if you send something different, the contract will not process our packet. We are only reading this kind of packet. Like I showed you before, We are only reading this data type. And we are sending it with a timeout. In this case, we are always sending 2 minutes. So our contract will send this. And like I explained before, the contract on the other chain will execute this because it will receive the packet. And that's it for the contract. So now that we understand how this contract works and how it communicates with the same contract on the other chain, let's look into how the channel works. So let's go to our tutorial. Here we explain all the basic. Here we explain how we deploy the contract on chain. But like you probably know this already, or if you don't know, you can come here to our tutorial and see how to deploy the contract. So let's see how we can create this channel so that all this logic can be executed automatically. First of all, we deploy our contracts on chain, on 2 different chains, okay? And we instantiate the contracts with this code ID that we have, and we will get a contract address. Once we have this contract address on each chain, we can query the IBC port of this contract. What is the IBC port? So the IBC port is the endpoint that our channel will use to connect to the contract. Why does our contract have an IBC port? Why did I never know about this? Well, because the IBC port is only assigned to the contract if we define this IBC endpoints. So imagine we have a normal contract with only execute, query, and instantiate. Well, our contract will not have this port. But once we define these IBC entry points for our contracts, the WASM module will automatically assign an IBC port to our contract, which has this format, by the way. It starts with WASM dot and then the contract address. Okay, so let's imagine that we have our contract in 2 chains, and each of our contract has this port. Okay. For this tutorial, I used the Coreum testnet and the Coreum devnet. So you will see that the ports have wasm.testcore and wasm.devcore. Okay. So what we have to do now, we have to download Hermes and configure it. I'm not going to go through this because it's its own process, but you can basically click on this link here, configure Hermes, and it will take you to the Hermes website, and it will actually explain you how to do it. So it's not that complicated. It's very straightforward. And once we have this Hermes relayer configured, we are going to create the channel. And here we have the example how to do it. We say Hermes, create channel. We define the ID of the channel, of the chains that we are going to establish the IBC connection with. In this case, for this tutorial, I use the Coreum testnet and the Coreum devnet. And since we are going to establish a channel between 2 contracts, I am going to define the endpoints of this channel as the first IBC port of the first contract. So the port on chain A, the IBC port of the contract on chain A, and on the port on chain B, the IBC contract deployed on chain B. And very important as well, I'm going to define the channel version as counter1. Like I mentioned before, IBC version, I defined it here in my contract, and I say it must be counter1 or it will not work. Okay, so I'm defining this. Once we have this channel created, we basically start the relayer. Okay, with this simple Hermes start command. And when we run this command, we will get 2 channel IDs. One will be the endpoint of chain A, and one will be the endpoint of chain B. And these channel IDs will always be different. So for this tutorial, I'm using this example here. So let's imagine that when we run this, it returns channel 2105 for chain A and channel 82 for chain B. Okay, imagine you get these two numbers, which will not be the case, but we are going to work with these two numbers. So now that we have this, we started the relayer, we have successfully connected our contracts. So we went through these two entry points. Nothing failed because we put the right version and the right ports. So it will go into this contract. It will save the channel number. It will initialize it with 0. Okay, and it will enter this correctly. Now, what we are doing is we are going to send an increment message, which is defined, like I said, here. And what this will do when we execute this contract with this increment message, like I mentioned before, it will send an IBC packet to the channel with the data. So we will basically, when we're executing this contract, internally, this contract will do the IBC, will send the IBC packets that the relayer that we have running will take and send it to the contract in the other chain. In this case, the Coreum DevNet. We probably need to wait 1 minute because the IBC transfer takes a little bit of time. So let's you ideally want to wait a short time. And if after this short time we query the counter on the other chain, which in this case is using 82, what we will get is that the counter has been increased by 1. Let me explain again. We execute this message in the contract that is deployed on chain A, in this case, the Coreum testnet. And this Coreum testnet contract will send an IBC packet that the relayer will take to the contract that is deployed on chain B, in this case, on Coreum DevNet. And it will increase it will enter this function. Sorry, it will enter this entry point here, and it will successfully increase the counter on this contract deployed on chain B. And if we eventually query to check what the value is of the endpoint of chain B, it will tell us it is 1 because we have successfully incremented. Okay, and we could do the same process, but the other way around. We could execute this message here, but instead of 2105, we would write 82, and we would execute it for this contract, and this would increase if we query this contract here with channel 2105, we would see that it would increment the counter by 1. And that's it. That's basically how contracts communicate with IBC. Just as a conclusion, well, you have all the information that you need regarding IBC and smart contract transfer on our official documentation. And one last thing that I want to mention is that in this tutorial, I've used the same contract for both chains because I wanted to make it not too complicated, but you can deploy different contracts on the chains so that as long as you define correctly what each contract will send and what each contract will receive, if you define it correctly and you handle the packets correctly, it doesn't matter. You can have different contracts with different functionality. You can make them talk to each other. The only thing you need to define is take into account is the channel ID and how you process the messages in the IBC entries.
Yeah, like where we can reach Coreum if we need like more information about this tutorial.
So in case you need help or you're not sure, you can always use our Discord. We have a developer channel there. You can leave there any question you have, and as soon as possible, we'll give you an answer.
Thank you once again for joining us, and have a great rest of your day.